16-2, and I'll do 16-1, which is similar, but your guys is different because your guys isn't equal, and so I'll try to give you some hints, I guess, on how to do that one. So we start this with our null hypothesis that pi is less than or equal to 0.5, and our alternate hypothesis that pi is greater than 0.5, and our sample size is 12. Our significance is 0.10. I didn't put that down here, but for one, it's 0.10. Okay, and we have to state our decision rule, and you can see I've got rejected null if our successes are greater than or equal to 9. Well, how do I find that? Well, I give you the pages and the appendix for you guys, 726 through 730, something like that. You come back here and it'll look like this, and the first thing that you have to find, it's about probably 728 or so, is the n, what your sample size is. So our n is equal to 12. Okay, and then we're going to use this column because of our hypothesis, right? Our hypothesis has to do with 50%, okay, the halfway point. And so make sure you use this column, okay? Then to come up with our critical number, the number for our decision rule that we had that was greater than 9, okay, because it pointed to the right, because our alternate hypothesis was that it was greater than, okay, then we know it's a right tail. Okay, we know that it's a right tail if you remember our normal distribution. Okay, so in that case, the book tells us, and we start counting from the bottom, or adding, okay, because we want to find the cumulative probabilities. And the cumulative probabilities then are totals as we go up here, but then that's where the 0.10 or significance level comes into play. What we want to do is get a cumulative probability that is less than our significance level. Okay, so let me show you what I mean here. So at 12, the probability is 0. Okay, at 11, it's 0.003. I add that to 10, and I get to, at 10, it's 0.016. So I add these together, and it's 0.019. Okay, and I can add 0.019 to 0.054, and I get 0.073. I'm still below 0.1, right? But 8 would get me up over the top all by itself, let alone cumulatively. And so 9 is less than, okay, and so I'm okay. So 9 is my answer, is my critical number, that I use for my decision rule. All right, so I reject the null if successes are greater than or equal to 9. Okay, and I imagine because it's, we only came up to that 0.73, that's why we say greater than or equal to. Okay, there we go, 9 or greater. B, we reject the null because it tells us then, right, it says that there were 9 successes. What is your decision regarding the null hypothesis? So it's greater than or equal to, so we would reject the null. Your guys' is a two-tailed test. Okay, yours is a two-tailed test. So let's say if number 1 was two-tailed, if this was equal to instead of, and I still had the 12n or whatever. Your guys' is a different sample size. Your guys' is 9. But then what would I do? Well, I'd have to take my significance and divide that. Okay, but I have to add. I have to add. See that guy's ugly mug. Okay. Then both sides. So I have to go from both sides. So it's 0 and 12 are both 0, 0. But 11 and 1, then I'm 0.006. I'm sorry, minus 0.10. So I could actually divide it by 5 and go from each side. How's that? So 0.05. Okay, and so I can go 0, 0. 0.003, 0.019 if I add those together. That would put me too high here all by itself, but I'm okay here. So this would be 2 or less, okay? And then the opposite up here, right, would be 10 or more. Okay, so if in my case, if I had an equal sign, I would say that I'd reject it if it was greater than 10 or less than 2. Okay, so hopefully that should help you then with your particular problem number 2.